All right, now I'd like to talk about another thing, which is called the point of inflection. And I'm going to go back to my cubic polynomial graph here. And the point of inflection is approximately here. So let me label it. I hope this doesn't get too cluttered. Point of inflection. All right, now what does that mean? Well, these graphs tend to have two basic characteristics. In this sense, on the left side of this point of inflection, the graph is looped over like this. And then on the right side, it's looped upward. And so on the left, we say it's concave down. And then on the right, it's concave up. So again, concave down means it loops over, concave up, it loops upwards. This function is what? It's looped upwards. It's concave up. But concave up doesn't always mean increasing, because if you look at this part here, this is concave up, but it's decreasing. But then it stops and goes back up again. So anyway, so concavity is also one of those things you can flesh out with some calculus. And but the point of inflection is a place where that can change. And so it does here. This point of inflection, it changes concavity around here, and then starts that opposite curl to it. Now, in real life, how do we apply these things? And when people use calculus or that other forms of advanced math like this, if in calculus we're interested often in trying to find these maximums or minimums, and because that may be interesting. For example, if you're building something and you're an engineer, you want to know where is the point of greatest stress, or in other words, where is the weakest point in your structure. And so that's finding a maximum or a minimum. This can be applied to business. Probably aren't too many companies out there that employ people who use calculus, but perhaps the largest ones do. They have engineers and people with some math background working in them who could analyze things. But you would always want to find ways to minimize your cost or maximize your profit in your operation. And theoretically, if you express all that in terms of mathematics equations, then you can find those maximums and minimums. As far as the concavity or the point of inflection, its application is sometimes we call it the point of diminishing returns. And so let me give you a quick example of point of diminishing returns. If you were to model an epidemic spreading, a disease hits a town, and now is assuming there's no intervention, medical intervention. When the disease enters a town, there are only a few people that have it, and so the amount of infections growing from them is increasing slowly, but it picks up speed as more and more people get the disease and are spreading it, until a point where it starts to slack off again. And there's a theoretical maximum up here of how many people who can be infected. So now if you're in my differential equations class, after taking some calculus, we actually model this. We come up with the mathematics of this. And you might be interested to know it comes from variation problems. It's a joint variation problem using calculus. Is where this model comes from. All right, so spread of a disease tends to kind of look like this. Unless doctors can swoop in and quarantine people and get people treated, then that's going to change the curve. But left unabated, this is about what happens, because again, at the beginning, very few people have the disease. They're not spreading it much, but as more and more people get it, more and more people spread it. And then at some point it has to slack off, because there aren't very many people left who can get the disease. And so at some point they're either dead or the remaining people are immune or what have you. There's fewer and fewer people who can continue to contract the disease, so it levels off. So where's the point of diminishing returns? Right there, you know, because here it's speeding up pretty fast and then it starts to slow down. So anyway, by the way, this curve is also called a learning curve, and except a learning curve usually starts about here. And because when you start to learn a new task, what you learn very quickly at the beginning, and then it slows down. And so the learning curve generally starts at the point of inflection. And so do advertising campaigns. At the beginning of an advertising campaign, a lot of people see the ad, and then there are fewer and fewer people left to see the ad. So it usually starts about here. But anyway, so there are some terminology, some ideas about how we can describe graphs. And we honestly don't exploit that a whole lot in this course. I may ask you to give me the intervals over which these things are occurring in a graph. And so I want you to know the increasing and decreasing aspects, know what a maximum or minimum means, or relative maximum, relative minimum means. And because I might test you on it if you're my student. And but beyond that, we can't do a whole lot with it because we need calculus to really analyze this in more depth. So, okay, well, let's move on.